Okay, we're talking about the time value of money. We have discussed the future value of a single sum of money and the present value of a single sum of money. And in each of those problems, when we were calculating it, I told you to zero out the payment. Now we're going to talk about that payment button on your calculator, which we're going to refer to as an annuity. In our previous lecture, we talked about discounting, where we transformed a sum of money in the future to some present sum amount. And we called that the present value of a sum of money. We laid out the formula for doing that, went through some problems in class to help us better understand that. Today we're going to talk about the future value of a series of payments. Instead of just a single sum, one sum of money, we're going to talk about how to evaluate series of payments. And then we're going to talk about a formula that we can use on finding the future value if it happens to be a uniform annuity, a uniform series of payments. Then we're going to actually start looking at how to use some of these formulas, and we're going to start with talking about a sinking fund, how that can be used for planned capital purchases, and how also the sinking fund can be used in a retirement fund. We're still in Chapter 9 on the reading assignments. And now let's talk about the future value of a series of payments. A series of payments is what we call an annuity. The problem that we're going to ask is how much money would you have in your bank account in 4 years if $100 is deposited at the end of the year for each of the next 4 years, and assuming that you're making 10% compounded annually on your money. And we start off, again, I've warned you that the verbiage in some of these problems get a little bit confusing at times. Pull the numbers out and put them in a timeline. That's exactly what I've done here. I've drawn the line. In this case, we have the timeline going 0, 1, 2, 3, and 4. Remember that you see 1 on the timeline, that refers to the end of the first period. Could be a year, could be a month, but it's the end of the first period, where the 4 represents the end of the fourth period. The 3 represents the end of the third period, but it's also the beginning of the fourth period. So it's important that you take note of that so that when we get a more complex problem, it's a little more understandable. And in this problem, we're saying that we're putting $100 into the bank at the end of each of the next 4 years. So if it's the end of the first year, the first $100 is going to show up underneath the 1 because the 1 represents the end of the first year. And the last payment is going to be at the end of the fourth because it represents the end of the fourth period. Then, in the timeline, we're going to put V4 under the fourth year because the question asks how much money or what value, what single sum of money are we going to have in our bank account at the end of the fourth year after we have deposited that last $100. Something to recognize also is that last $100 does not draw any interest. There's no time because that's the point that we're valuing the quantity of money that's in our bank account. And we've also assumed in this problem that the interest rate is 10%. Hopefully what you recognize is if you look at the problem on the previous slide and then put it in terms of the timeline, what seems to be kind of a tough question is laid out very simply in the timeline. And that's why it's important that in types of problems that you extract the information you need and put it into a format that you can use to analyze the problem. Now in this particular case, what we're going to do to figure out this V4, we're going to take each cash flow, we're going to do it separately, and then we're going to sum up each of the quantities. All right? That's the process that we're going to use to solve this particular problem. And we first start with the first $100. Now there's something that's actually quite easy to recognize because we're looking at this $100 that we get at the end of the first period, and we're going to compound it to the fourth period. How many periods does that compound? Do we have interest? We have 1, 2, 3. So it shouldn't surprise us then that we're going to compound that for 3 periods. If we take the amount that we put in the second period, notice it accrues interest for 2 periods. We're using the future value of a single sum of money to do this. We're using the future value of a single sum of money to treat each of these cash flows. The third one, you can see is only in interest for one period at 10%, and then the last sum of money, it doesn't accrue interest, it's just the $100. Then to find out the future value of the series of payments, so in this case, to find the future value of this $100 annuity for 4 periods, we can see that the answer is $464.10. So how much interest did we earn on this $100 annuity? $64. We put $400 in principal. At the end of 4 years, we had $64.10 in interest that accrued at 10% over this period of time. To find the future value of a series of payments, we're going to take each one, treat them separately. We're going to transform them appropriately for the appropriate number of periods to find its value in the future, and then sum them up. Now, if we were to do this in Excel, we're going to digress to Excel, we could lay this out by putting $100 in these cells, but to calculate this answer, notice that, just like we did in the previous slide, we're going to take each of these cash flows and we're going to basically compound them at 10%. This one's for 3 periods, and there's $100. For the second sum of money, you can see again that we're compounding at 2 periods, and then in the third period it's 1 period, and then for the fourth period it's just $100. Even in Excel, we do it the same way. Instead of using your calculator, you're using the formulas, and notice that you're adding them up. Okay, just like we did, we summed them up. Okay, the formula for this is a little ominous. I don't expect any of you to memorize this to give it back on an exam, so that's not the purpose of this. It's so that you have completeness, because some of you are going to go on into the next levels and you're going to be programming these types of problems. I want you to have the complete formula. And basically it's not all that difficult. This summation just means that we're summing up quantities of money, and that's what we did on the previous problem. We're starting at time 0. We're taking the payment, and for each payment we're compounding them the appropriate number of periods. It shows up in these exponents. You can actually plug in those numbers if you want